Alright guys, so today we'll discuss, because we haven't spoken about this before, 4.3.3 exception handling. It's part of the A2 computer science syllabus, further programming, code 9608, compiled from the Cambridge A-level book. Alright, so firstly, syllabus contents, all you need to know and all you don't need to know. The best way, in my opinion, to study is from the syllabus. So, firstly, we need to show understanding of an exception and the importance of exception handling in programs, to show understanding where it's appropriate to use exception handling, and write code to use exception handling in practical programming. And practical programming refers to pseudocode and your programming language, like Visual Basic or Python. In this presentation, I covered VB, but if you want to look at the Python code, you can see the book. I think it's page 365 for the code. Okay, so secondly, understanding exceptions. So the definition, importance, and uses of exceptions. What is an exception? As you can see with the apple here, the red apple in between the green apples, is basically something that a rule doesn't apply to. Something, if we generalize an entire rule, and then you have the one exception. I mean, we take physics, we know how many exceptions there are to rules, so this is basically the same thing. So an exception is an error that occurs during the execution of a program, a runtime error, all right? Exceptions can occur due to a handful of reasons, including division by zero, trying to open a non-existent file, and entering a string value into a variable with the integer data type. So far, in the programs that we have made, whenever such errors would occur, our programs would crash and fail to resume operation. This is because we didn't make use of exception handling in our programs. Exception handling is vital to the development of a program that is intuitive and bug-free in the real world. So, like Isa said, do you remember when we tried to do validation for the integer? So if you enter a string value for this is how we're going to do it. Basically, because we didn't use this method, it would always fail whenever we tried to put a string value inside the integer data type. So now we show, that's the point in the syllabus completed, show understanding of an exception. Okay, exception handling. Exception handling is the process of resolving exceptions using an exception handler. An exception handler is a fancy term for an error subroutine. It is essentially an algorithm, a series of steps that is used to deal with exceptions rather than allow them to crash the program when they occur. It is basically a glorified failsafe in case anything goes wrong. If exception handling was not used in a program and an exception occurs, the end of file is encountered and the program crashes. This is why use of exception handling is of significant importance when designing software. I know it may not make sense right now, we're going to get into the specifics in a little bit. So now, in general, we show understanding of the importance of exception handling, which is basically that without exception handling, when an error occurs, the program crashes. Yes, okay. So, when to use exception handling? Right. So a reminder, error handling is essential because it can help make the program error-free. An error-free program runs smoothly and the user doesn't face program crashes or non-responsiveness. Errors often occur due to incorrect input from the user. It would be wise to set up exception handlers for incorrect user input, such as dividing by zero or inputting a string into integer data type. A good programmer should be alert to the parts of program that could trigger errors and should write exception handling code to keep the exceptions under control. However, there should not be too many exception handling codes in the program, as that creates problems for the programmer to maintain and troubleshoot the program later. Basically, the more exception handling codes you have, the more you have to manage with the errors. We're going to see code right now, but basically it's more of a hassle. So not too many lines of exception handling codes. So now we understand when it's appropriate to use exception handling, which is basically when we need to make sure that user input is correct make sure that incorrect user input won't crash the software, and to make sure that the program is error-free. Okay, thirdly, practical coding. Now this is the part where, this is the meat of the syllabus point, putting theory into action. Okay, so exception handling pseudocode. Right, so basically it's just 5 lines of code. This is literally it, right? It's try, accept, and end try. Between try and accept, this is called the try block. Everything after try, so between try and accept is called a try block, right? And then this is called the accept block. Yeah, same thing. Okay, so we explain the code. The general syntax of exception handling is try, accept, finally, and end try. Finally may be there and it may not be there, depending on the situation. And I'm going to explain what finally does as well. Okay, so the lines of code in the try block are used to try and cause exceptions to occur, to catch out any mistakes in the user input. So see the next slide. All right. So we can see the next slide for more information, and I'm going to discuss that in a bit. But basically, the try block, these lines of code right here, they are used to actually try and catch out the user input or the lines of code to make sure to basically try and cause an exception to occur, so that if it doesn't occur, you know 100% that there is no exception. So that's what the try does, the try block. Then you got here the lines of exception handling after accept, which is basically the accept block, catch any exception. And an exception is a runtime error again, during the execution of the try block. So once the exceptions are caught, the lines of exception handling are executed, and the exception is successfully resolved. So basically this means that here, if an exception occurs, this catches the exception. Basically, when an exception occurs, these lines of codes are executed. That's what that means. So this thing here, it tries to cause an exception to occur during the running of the code, during the user input, and then if an exception occurs, then this block here is executed to try and resolve it instead of having the program crash. Okay, so now there can be more than one except block, each handling a different type of exception. So you could have the original lines of code here, and then here except for one type of exception, and then except for another type of exception, and then a third one for another. So basically just different types of errors could be caught in the same exception handling code. Alright, so sometimes a finally block follows the except blocks. The finally block is simply a continuation of the original lines of code in the try block. Whether there's an exception or not, the finally block is always executed. Basically, finally is just lines of code that are executed after try, except, and they're always executed. These are the basics of exception handling. With more practice, you'll know how to deal with this type of question. So that's write code to use exception handling in practical programming done, or half done because we didn't do VB yet. Okay, so exception handling in Visual Basic. So as always, the VB code is highly similar to pseudocode. Can you spot the one difference from pseudocode in this line of code here?
Catch.
Yeah, it's try, catch, and end try instead of try, accept, and end try. Yes, it's try, catch, and try instead of exactly. So it's literally the exact same code with the exact same idea. There's no difference whatsoever. That's the beauty of VB. If you actually look at the Python code, it's quite complicated. So basically, it's the exact same idea, and we're going to look at an example right now of how it's implemented. So example of exception handling code. So what is the purpose of this code and how does it work? Who can try to explain what's going on here? So okay, what's the first thing going on here? What's the first step we're doing? Yeah, number string. The variable number string is we're putting a value into the number string. Okay, so now what's going on here?
You're assigning a variable.
Okay, so what's this right here? What? Yeah, so what's int right here? What does that mean?
Integer?
Yeah.
The integer. All the integers on the number string. Oh wait, is it numbers? You need to show n is an integer.
Okay, so no, what it does is it tries to. Okay, what's int? Sir, can you help us out here? What's int?
Here, this is a type of conversion for the string value, right? To an integer. Okay.
Yeah. So n equals int. So basically, it converts the number string into integer, right? And then console.writeLine n. Now, if any error occurs during this, right, it catches the exception here. You understand what's going on? So, if an exception is thrown here, it catches the exception, and then it says this was not an integer. So instead of having the entire system fail, because if this here was like ABC, can you convert ABC into an integer? No, you can't. Which means it's going to throw an error. It's going to say, okay, it's going to throw an exception. It's going to be like, well, we can't convert that to an integer, so it's going to crash the program now. Well, now instead of having it crash the program, it just catches the error, and then it says, all right, this was not an integer. You're inputting it wrong. This isn't the way it should work. So again, the try block tries to catch the code out, tries to catch the user input out. If the input is correct, like 1, 2, 3, then excellent, it works out and there's nothing to be caught. Whereas if you input it wrong, try is basically when you're in airport, when you are in an airport and you have the metal detection system, that's try. And catch is the security guard behind it, essentially. If you're trying to sneak in a bomb, you're going to jail, basically. This is what's going on. All right. So lastly, recap, just a few sort of recap questions. Okay. So, were you sleeping? Define the following. Exception. It's an error, yes. But more specifically, it's a runtime error.
Yeah, I see.
Yeah. A runtime, what's a runtime error? What does that mean? Yes, yeah. It's an error that occurs during the execution of a program. Yeah, yeah. So it's not like syntax or logic errors where it's just a runtime error. Okay, so exception handler. What's an exception handler? It is very similar to a program. It's an algorithm.
It's an algorithm that just carries out.
Yeah, it handles the exception. It just handles the exception. It basically deals with the error that's produced. And then you got exception handling, which is the use of exception handlers to handle exceptions. All right? Okay. So, answer the following questions. What is the importance of exception handling? Come on, this is easy.
It's important to make the program function and not crash.
Not crash. When an error occurs, when a runtime error occurs, to prevent the program from crashing. Okay, and then when is it appropriate to use exception handling?
When there's a runtime error.
Yeah, when there's runtime errors, when we want to check user input for the correct data type, to make sure they're not dividing by 0. Okay, those are the sort of examples. Exception handling 4.3.3 is now done.
Thank you.
Okay, so this was Anas Khalid A2 level computer science 9608.